So I'm glad you're all, a lot of you are here. So I'm kind of new to learning about inequality as well. So hopefully we'll all kind of work together on it. And I'm going to come at it from a very different angle, probably than from the stuff you've seen before. So, I like diversity. It sounds like we have a very diverse group here, and that's good. So maybe I can teach you some things, maybe you can teach me some things. All right, so here are the questions that I kind of want to think about when I'm thinking about inequality. And I'm a macroeconomist. And macroeconomists you don't think of macroeconomists, the first thing you think of is not inequality. Okay, so these are kinds of questions that may come from the standpoint more of a macroeconomist, but I'll give you a sense of what we think about. So in these lectures, I'm going to address the following questions. So first of all, if financial markets are incomplete, so what do I mean by that? I'm just going to say, I mean that there's not a full set of very sophisticated financial markets. So obviously in more developing countries, this is much more important. In the US, we have pretty sophisticated markets, but we don't have perfectly sophisticated markets. So we're going to start with an environment where the financial market structure is not necessarily, perfect. And the word we use for that is kind of complete. So you can't insure away all, idiosyncratic shocks to yourself. Okay, and the shocks that we're going to be thinking about in this context are earnings shocks. Okay, there's a lot of good reasons why earnings shocks may not be, you might not be able to write assets thinking about earnings shocks. I mean, if someone says I can't work and they point to their back, my back hurts, it may be very hard to verify that, right? So these kind of markets are not necessarily, it's not easy to set up markets that kind of handle that kind of a situation. So, I'm going to try to keep this set of lectures, I'm going to try to teach you kind of the simplest possible model to think about the data. So, in this kind of a framework, I'm just going to think about there being a bond market. So a bond market, a non-contingent bond market, and that's a market in which, I can borrow, I can save, but I can't, the bonds are not contingent upon what happens to my earnings, okay? So that's the sense in which, so I was saying that I'm going to have a non-contingent bond, there's going to be a borrowing limit, that's going to be important for how you can smooth your earnings shocks. And so what I want to focus on is how much does earnings inequality account for wealth inequality? This set of lectures is going to be basically about understanding wealth inequality. We're going to take the earnings inequality as kind of given and see what the implications of the earnings inequality is for wealth inequality, okay? As you'll see when I talk about some data, earnings inequality, there's less earnings inequality than there is wealth inequality, okay? So the model that I'm going to write down and teach you is going to have to kind of amplify the earnings inequality, okay? And so I'll take you through a framework to think about that. Okay, so one of the questions is how well does this model do that I'm going to write down? And as I said, I'm going to write down the simplest possible model. So if it explains a certain amount, maybe half of it, I might feel okay. And then the goal for all of you as students are to kind of think, what do I have to do to this model to account for more of the wealth inequality? So that's the research agenda in some sense, okay? So, so another question we can answer or try to answer is how much would people be willing to pay for better or more complete financial markets? We'll do this in the context of how much people would be willing to give up of their consumption in order to get sort of full insurance against earnings shocks. Okay, there's a famous, Bob Lucas, who's a Nobel laureate here, he had a famous kind of a question a little bit like this, which was how much would people be willing to give up to get rid of business cycles, okay? And the answer was something like 1/1000th of a percent, so not very much. So when I put up the number that I'm going to answer question 2, it's not going to be a big number, but it's going to be bigger than that. Okay, so the question is sort of, one way to think about that is how much. If it's not a big number, maybe that's a reason why, if it's costly to set up financial markets, maybe that's a reason why you don't actually see perfectly complete markets in the real world. Okay? Yes, it's very sensitive choice of utility functions. It's under complete markets. Once you put in incomplete markets, the number becomes bigger. Okay, so I'm going to have a very, so the preferences that I'm going to be using in this are going to be such that it would give that kind of a small number. Yeah?
Will the number that you tell us from questioning to give us a sense of it, give us some benchmark for like understanding like did it make sense for the government to step in like during the crisis or not? Like, should we think about it in those terms?
Yeah, I'm gonna get to a question that I think of. These two questions are even more about the crisis. Okay, so the next two questions are more like that. So, by the way, I'm happy to have you ask me questions. I may not be able to answer some questions. I may have to think about them and then tell you in office hours later. So I'm totally into getting questions. That's more fun. The only other problem is that I have 100 slides, I realize. So that gives me 2.5 minutes, and I'm already probably 5 slides behind. so let's keep talking, but I may have to say, well, I'm gonna go to this. All right, so here are the two questions I think are very relevant to the question you asked. Because these, in my mind, I fashioned these two questions thinking about the recent financial crisis, okay? So the first one is, if borrowing constraints become tighter, okay? So, you hear about this all the time. People can't get mortgages anymore, et cetera. That's a sense in which the constraint, how much you can borrow, has become tighter, okay? And so we can ask the question, how does that affect wealth inequality? Okay? We can also ask, how in terms of these welfare, and when I say welfare, what I'm thinking about is, again, how much would people be willing to pay to get rid of this stuff? That's the kind of way that Luke has thought of it. So what are the welfare effects of tighter constraints? Okay? And then the other question that's kind of, I think, relevant in terms of the financial crisis is how much does a doubling of unemployment durations, how does that affect wealth inequality? How does that affect welfare for people? Okay, so these are the kinds of questions that I'm gonna kind of give you a model that I can actually give you answers. Quantitative answers, like numbers, for that, okay? And the bottom line is I'm going to put this, I have the code for this, and it's on the website, so you can kind of change parameters and ask, answer new questions, okay? Yeah.
I guess just to go back to Peter's point, I know in macro we always think like how much would you pay if I could give you arrow with your securities, so we think of it as financial markets, but you could also think of that as being how much would you be willing to pay to have a bigger family to insure you or something like that.
Exactly. So, absolutely. So the unit that I'm going to have right here is just going to be, when we take this to the data, we're going to start to think about households. So the measurement is going to be a household, but I'm not going to actually measure the endogenous formation of the household. But that's absolutely right. And there are papers that I think of as being, macro types of papers that actually deal with that. There's a current paper by Greg Kaplan, who's at Penn, and he actually kind of thinks about, why have so many younger people started living with their parents again? So that's, and it's an endogenous choice. And I'm not going to model that, but that's the kind of stuff, that's why I'm saying, take this kind of framework and then think about interesting questions like that. I'm going to kind of say, here are all the things that we haven't endogenized in this framework, and yours is another one. And I'll actually talk a little bit about family status because that's some of the data has to do with that, but not for this model. But I'll point you in the direction for that. There was yeah.
Are you also allowed for the fact that people might have tastes over equal or unequal distribution?
Yeah, I'm not, these are all, you see, this is all good stuff for you to think about to change this kind of framework. I'm going to give you just a real simple framework to think about. Okay? All right. So these are the questions. All right? And I said I'm a macroeconomist, so now I kind of want to give you a sense of how macroeconomists come, and think about this stuff. So, what does macroeconomics have to say about wealth inequality? For those of you who are economists in here and who have had a first year, macro class, typically you kind of work within this paradigm called the representative agent paradigm, okay? And that's where there's complete markets. And that says nothing about inequality, okay? So, in that case, even if everybody experiences idiosyncratic earnings shocks, the complete assets, perfectly smooth income and consumption, the wealth distribution is indeterminate. It's got nothing to say about this stuff. So, but once you have incomplete markets and agents can't perfectly insure, then the wealth distribution becomes determinate, okay? And that's what we're going to be working with today. This framework that I'm going to be kind of teaching you is in macro. It's kind of called heterogeneous agent models. The person who kind of developed that was Truman Bewley. I like to say Truman Bewley because that was my advisor. And then the other, if you actually look in Lundquist and Sargent, the whole part 6, I think, is they call it Bewley models. Okay, and that's this framework for thinking about things. But if I want to think about the data, I have to make that framework quantitative, and that's what some other people did. Truman didn't. Truman's paper was, papers were purely theoretical. The quantitative nature kind of came from papers by Rao Ayagari, Aisha Imrohoglu, and Mark Huggett, and that happened about 20 years ago. Actually, the simplest possible model that you can use to study this is a paper by Mark Huggett, and I'm going to make it simpler, okay? Because I think that's, let's start simple, okay? Okay, so now I have to kind of tell you what we're going to do, okay? So what's the methodology that we're actually going to use? So it's going to be a general equilibrium model. So interest rates are going to actually be determined endogenously. Things that happen to the shock process are actually going to change interest rates. I mean, currently, if you think about what's happening to interest rates, admittedly, a ton of what's happening to interest rates right now is, government policy kind of moving interest rates. But the fact that people are saving more now than they did before the crisis has an impact on what's happening to interest rates. Okay, so this model is going to, one of the objects that's going to come out of it is an endogenous interest rate. The actual model is going to be, people are going to receive persistent, and that's going to be consistent with the data. I'll talk about earnings shocks. What we're going to input into the problem is an earnings shock process, and there's going to be heterogeneity in that. Okay? And then all they're going to be able to do is insure themselves through non-contingent assets subject to borrowing constraints. So as I said, the second bullet point is kind of how we're going to do it. The basic methodology is to input an exogenous earnings shock process into a model to obtain endogenous asset decision rules, and then the wealth distribution. I kind of like to think of this is kind of like the way I'll think about solving the model. Okay, we're going to put in this exogenous shock process. For this particular problem, it's going to be earnings shocks. Okay, for those of you who are familiar with, who have taken a first-year macro class, I figure maybe a lot of you have never taken. You said, "Oh my God, that's terrible. I'm going to get out of macro." So I won't. You may not have seen the stuff I'm going to teach you today, but you've all probably seen something like a real business cycle model, potentially. In that kind of a framework, the exogenous shock process is our technology shocks. The model is called a stochastic growth model, And what comes out of it is basically a law of motion for capital holdings over time. Okay? That's the standard thing that I think all of you have probably seen. In the framework we're going to put here, there's going to be an earnings shock process. I'm going to put it into an incomplete markets model. And the endogenous process there, I'm going to kind of get two things out of that. Okay? I'm going to get an endogenous people's savings decision rules. And also, when I couple the decision rules with the shock process, it's going to generate an endogenous cross-sectional distribution of wealth. Okay, and that's the thing that we're going to look at. That's going to generate model, predictions about moments that you guys are interested in. One of the moments that I believe that you're all interested in is the Gini coefficient. Okay, that's a very nice, simple summary statistic of inequality. So we can take out the endogenous cross-sectional distribution, and from that distribution we can compute Gini coefficients. And then we can ask the question, how does that Gini coefficient that comes from the model compare with the data? Okay? All right, so that's what I was saying here. We can compute summary statistics like the Gini coefficient to analyze positive and normative questions. So here is the explicit question that I'm going to start to think about. How much wealth inequality as measured by the Gini coefficient can be explained by individual specific earnings shocks in a simple incomplete markets model? I mean, two things to note about this question is that one, it's kind of quantitative. It actually asks the question, how much? So I'm going to have to come up with a number. Okay? I think it's kind of fun because then it's easy to remember a number. Okay? You go out to the bar, you can probably remember a number. Okay? You might not remember the model, but you can remember 1/2. Okay, and then the other part of this is if it uses the words model, so I'm going to have to have a model. We're going to call this a structural model. But it also, when I say how much of wealth inequality, I mean in the data, right, or as measured by the Gini coefficient in the data, can be explained by the model. Okay, so we have to compare data moments to model moments to answer that question. Okay, so that's going to determine what I teach you today. I'm going to talk about the actual data that we're going to use to kind of think about these questions, and then I'm going to have to teach you a model. Okay, so the answer here, for this particular case, I don't know whether you think this is good or bad. Okay, but here's where I got the number, 1/2. Basically, when I show you this model, you're going to say, that is so, for the reasons you just said, right? I mean, in the real world, there's family insurance. I'm not going to have family insurance in the model or anything like that. And I'm still going to, this simple model is still going to explain about 50% of the wealth Gini, okay? And, I have a quote later on. I mean, explaining the tails of the wealth distribution, this is really hard, okay? So, that's where I think the forefront of research is, and that's what, you guys are here to kind of do that, okay?
Dean, what is the assumption about the distribution of that?
It's going to be, I'll show you. There's a mobility matrix that you can get from the data. The epsilons are going to simply be, it's going to be a Markov process. Just a simple two-state Markov process for this model, and the way I'm going to parameterize that Markov process is off of basically data on replacement rates. I'm going to think of this simple framework. The two states are going to be people who are employed or unemployed, and then I'm going to take data on durations of unemployment and the aggregate unemployment rate, and I'm going to use that to kind of pin down the two-state Markov process. Right, and that's why this one is not going to do well at all about matching the tails. This earnings process that I'm going to put in is so simple, it's not going to, match the tails. I mean, what's kind of interesting is the earnings process. The Gini on the earnings process that I'm going to put in, there's very little inequality. In fact, the Gini coefficient for earnings is 0.003. I should have had that up on on a table that I'm about to put up. But that means that I'm getting a lot of propagation and amplification just through the model and not through the earnings process. So if I give it more diverse or earnings processes or fatter tailed earnings processes, hopefully that would even amplify the gene
I
more.
wasn't concerned about the gene so much. I was the model that you do on the tail. So when you children thin tails for the shock process.
Yeah, this process does not have thin tails for the shock process. Okay. So I've kind of said a little bit of this, but so let me go through this quickly. Remember, I only have 2.5 minutes per slide. So I'm going to start with this underlying exogenous earnings process. Yt+1 is going to follow, for the computer code that I give you, it's going to be a two-state Markov process. The shocks are going to be IID across agents. And so with enough agents, so we're going to have a continuum of agents, you think that basically the law of large numbers is going to hold. And so there's going to be no aggregate uncertainty. There's just going to be this idiosyncratic uncertainty. Okay? We're going to solve for this sort of the savings and borrowing decision rule. I'm calling that the precautionary decision rule. As the decision rule is going to depend upon what your assets are today, what your earnings is today, and you're going to determine how much you want to save or borrow tomorrow. That's what this is saying. Now, how much you do of that is going to depend upon parameters of the model, and we're going to choose the parameters of the model to match certain moments in the data. Okay? So, the next part is, suppose everybody, just do this thought experiment in your mind. Suppose all of us started out with the same, 0 assets, okay? And just suppose for the time being that if you're employed, you want to save. If you're unemployed, you want to borrow, okay? Then, then we start flipping a coin, and it's going to be a coin that's not, it's not a fair coin. Let's say 5.66% of you are going to get a tail, which means you're unemployed, and 1 minus that is going to get heads. You're going to be employed. So that means we all started out with 0. After the flips of this coin, if there's enough of you in the audience, basically 5.66% of you are going to go this way, and 1 minus that is going to go that way. So we started off with 0 assets. Now all of a sudden, after one flip of the coin, the wealth distribution fanned out, right? And then we're going to put that in, basically that logic into the model, okay? So that's, given incomplete markets and idiosyncratic earning shocks, even if everybody starts at the same wealth level, the wealth holdings next period is going to be different, okay? And so what, in the limit, we're going to, solve for an endogenous cross-sectional distribution of wealth. Here's the cross-section, for a given earnings level, there'd be a cross-section across wealth, okay? So there'll be a wealth distribution for the unemployed, a wealth distribution for the employed, et cetera, okay? Yeah?
And are those flips across periods going to be, what are we going to assume about those flips across periods?
They're endogenous. Oh, you mean the flips of the coin. The flips of the coin are exogenous. That's from the earnings process. So again, that's where even the stuff that Lance did yesterday, in some sense, a model of human capital accumulation will have something to say, will endogenize the flips of the coin. But here, I'm going to keep it so simple. Okay?
So we can think of the flips of the coins like the probability that you work in the period.
Yes. Yeah.
Conditional on having worked in the previous period, your probability of working in the next period is independent of that.
Well, conditional on what you did this period, right? So the stochastic process is going to depend upon unemployment today, let's say. So my unemployment or my employment today, tomorrow is going to depend upon what it is today plus a flip. That's this process, right? So my employment status tomorrow is going to depend upon my employment status today plus a shock. The shocks, these epsilon t+1s are going to be IID over time. Okay?
It's not like a threshold decision rule for if the right hand side of is the threshold then you would work if it's less?
Well, this thing is just going to be exogenous, so there's not going to be an endogenous threshold along that dimension. Okay, so this is kind of the, all I'm trying to get out here is for you to kind of see what I want. You're going to get two, here, the endogenous things that come out of the model are going to be both this savings function and a cross-sectional wealth distribution. Okay, those things are going to be endogenous. So something, that changes policy or whatever, potentially change all these things. Anything that changes this parameter, might be standing in for some kind of a policy as well. You change that, the model, I should have put let's say the model has this thing called, there are parameters of a model. And when I change that, I'm going to get out a different process. Okay? Okay. So once you have these two endogenous functions, you can generate many different model moments to compare with the data moments. So what we'll do is actually, this is the process. I hate using this word because it's got such a bad connotation. But calibration, I'm going to calibrate, okay? Because that's the simplest possible thing. If we had, 20 hours, I'd teach you how to, estimate these things. But this is supposed to be about, not so much about estimation and all that and finding the right parameters. It's about kind of thinking about the wealth distribution. I want to do this in the simplest possible way. So when I say over here, choose parameters theta so that model moments match certain data moments, again, you could do something called simulated method of moments. You'll get standard errors, all that kind of stuff, okay? Right here, I'm just going to do it really simply, okay? But the idea is that once I get out this endogenous, process, then I can compare the things that are endogenous, change the parameters. This thing, just to be, this would have a semicolon theta, okay? Because the decision rule is going to depend upon the parameters. And so it's going to generate, the model would potentially generate a real interest rate, let's say, okay? And I'm going to compare the model interest rate to the data interest rate. And then I would choose another parameter to bring those close together, okay? Simulated method of moments is just a sort of a rigorous way of doing that, okay? Again, that we should leave that to other, times. That's what I would, and the particular thing that the model I'm going to show you today is I'm going to, calibrate parameters to match these two moments, long-run unemployment and real interest rates. And then there are things that are not going to be, I'm not choosing parameters to match, okay? So, this is, oftentimes we call this an over-identified model. There's lots more moments that the model spits out than, the parameters we have in the model, okay? So that's often, you think about that as being an over-identified model. So then that way we can kind of test the model by how well it does on other moments. So the thing I'm not going to target here is the Gini coefficient, okay? And that's why, it's kind of like a test of the model, how well it does. And so again, as I said, I'm only going to match 50%. So you can say that's either good. It's whether you see the glass half full or half empty.
Right? Match the Gini coefficient and see the implications further.
You could do exactly that, okay? Since I'm teaching about wealth inequality, I figured I'd try that. I don't know how well the model, this simple model, would even be able to do that. I'd have to really play around, as you were saying, I'd have to really play around with this earnings shock process to be able to do something like that. I definitely think that would also be informative. Okay, so here's an outline of what I'm going to do. So remember, I said the question we want to answer is this. So as I said, I have to know something about data to be able to answer this question. So in that case, I have to I want to kind of tell you a little bit about data, the way that, the way I know about it, okay? And I am almost certain that 95% of you know more about the data than me, okay? But I'll tell you what I know. And then I'm going to, build this model. And then I'm going to do these 3 experiments. I'm going to assess the welfare costs of market incompleteness. I'm going to tighten financial constraints, like what just happened in the recent crisis. And I'm going to also, as a separate experiment, I'm going to raise the duration of unemployment. Okay? And we're going to see how much worse off are people, okay, from each of these things. We can actually use the model. That's the part where having a model, we can make welfare calculations. And as Stephen said, welfare calculations depend upon the preferences you put into the model, right? So I'm going to put in preferences that people are not all that risk averse. And still, you'll see that the answer to this, well, I'm going to get to it, so I'm now like 20 slides late, I'm sure. So let's, and then if I have any time, I'm going to talk about, both endogenizing the borrowing constraint. I'm going to take a borrowing constraint that's completely exogenous. It's going to actually, the one that I'm going to start with, the benchmark, is going to be two times, you can borrow up to 2 times your quarterly earnings, okay? And then I'm going to think about what happens as I cut that in half, okay? But that's just exogenous. I'm just doing that stuff exogenously. Borrowing constraints typically are endogenous, and I'll talk about that's where, to be perfectly frank, that's where I've done most of my research. I also, as we were talking, I'm going to take this totally exogenous earnings process. As you note, I don't even have sort of other, I could have, like, the X that I'm going to have in here doesn't depend upon your age, okay? Stuff like that. So it's, the earnings process, and when I show you the data, and you all know, there's a hump shape in earnings, okay? So to do a better job of trying to match the wealth data, I would, want to think about inputting in an earnings process that was also age dependent, okay? I'm not going to, that's just age is exogenous, but then once you put in age, you start thinking about human capital accumulation decisions in youth, okay? And that's how you would endogenize this stuff, okay? And then finally, you can start to think about endogenizing redistribution. I actually think this is where there's so little work done, and I think it's very, very important. Because, think about, I'm going to generate an endogenous cross-sectional distribution of wealth. Now, if you think people vote with their wallets, right, and that's what we always hear, I don't know, that's what I hear on NPR, then I can use this model, right? If I think about a median voter, then the median voter, is in the middle of my wealth distribution, my cross-sectional wealth distribution, and that person's making a choice of how much redistribution to do, but that choice affects, their income. That's a hard problem when you start thinking about it, because now that's a problem where one person actually kind of controls the state of the entire economy, the median voter. So that's a huge fixed point problem that you have to solve. Okay, and I'll talk a little bit about that. I mean, some people have worked on that stuff, so I'll talk about that.
Yeah, I give you a little bit of a hard time. Why would this be the right model if I wanted to talk about median voters?
About what?
Political economy. In other words, you want to develop an environment in which fairly neoclassical reasoning plus incomplete markets can generate wealth distribution. Now you've suddenly thrown in a completely different dimension where Theodore's question, for example, about preferences with respect to...
I totally agree. So you have to...
It would all kick into play. So I would have thought that one thing to say is this model is designed to analyze certain questions. If I want to know what the voting patterns are, you would observe it with respect to redistribution. I design a different model.
Actually, okay, so here's where I don't have enough time, and I definitely would like to talk to you about it, because I think this model is okay to do it. Okay, and we'll get...
If you can predict a lot even without including other preferences that would be
Pardon me?
If you could with your model predict enough of what you observe in the data in terms of what is voted for, even without including how we got incompetence.
Well,
Yeah, so
I know enough about it, observe voting patterns where this would be a problem.
Well, so this is what's kind of, I mean, I think that the models, so now you can see, this is great for you to see because this kind of says that this is an area of research that would be good to do, right? Because okay, so, yeah, we'll discuss, I have a paper on this, and so we'll talk about, if I get enough time on this, so I think that I think we can do a little bit of what again, we don't explain all of what happens with the redistribution. But one of the important things is, one of the things that's changed, so here's what we did in this other paper. We kind of looked at we normalized by the middle quintile, basically, earnings and stuff like that, and effective tax rates. And what you saw, two things that have happened in the, over the last, let's say, 30 years is a fanning out of the earnings. So earnings inequality has gotten bigger. You also see that the median, basically the mean has grown a lot relative to the median. So there are kind of two things, both the fanning out of the of earnings, which with concave preferences would mean, maybe you want more redistribution. But the other part about the change in the median to mean means that people, if the median voter is getting, poorer, then you might get more redistribution going on. So the model might be able to actually explain why the changes in there's been more redistribution going on. Normalized, again, this is all normalized by, we're not taking into account how the actual level of tax rates change, just how they're relative to the median. So it does some of that stuff. I don't know if it's the right way to think about it, but we can talk about it. Yeah, go ahead.
Have you thought about thinking into mobility? So maybe if there's a high mobility, people kind of think that they might be in some unequal distribution.
Yeah, exactly. I mean, that's what that paper does. The mobility part, in that paper, it's wages and earnings are endogenous, okay? And that, so what happens in terms of tax policy affects, basically.
Well, maybe mobility affects the way you vote because you kind of feel forward.
Right. And so if you put in if you change mobility, then you also change how you tax, how you redistribute and stuff. Yeah, definitely. Okay, so these are the things that we're, I want to try and do. And I'm already, now I'm 30 slides behind probably. Okay, so here, let me give you sort of so here, let me give you kind of a brief, sort of a view of what's going to come. So here's a very simple parameterization. The model period in this model is going to be a quarter. Again, it's going to be this simple incomplete markets model. There's really only, these are the parameters in some sense. These are the only parameters in the model. That's why I said it's so darn simple. There's going to be, a discount factor, beta. I'm actually going to, in some sense, we're going to think about one way you can think about doing the problem, though it's not the main data moment that's going to kind of help identify beta is going to be the real interest rate. I'm just going to take a coefficient of relative risk aversion of 1.5, so that's where I was saying it's a very, very low degree of risk aversion. So you would expect lower numbers for welfare gains and losses. I'm just going to think about people being employed and unemployed. So I'm going to normalize earnings of the employed to 1. If you look at replacement rates, basically, like in the US, it's maybe a half. So that's where what you get if you are unemployed is 0.5. Then I'm going to take data on durations and unemployment to aggregate, long-run unemployment to pin down the two probability probabilities from the two-state Markov process. So these four cells basically make up what would be the mobility matrix in the model. Okay. And then this is just simply the borrowing constraint. And I'm going to just say that you can borrow up to twice of your income. So this is really simple, okay? And here's what you get. So as I said, I actually chose the parameters to match these. So that's why I said targeted. So it's no surprise that the model matches. I chose parameters to match these two moments, okay? The data, this is all from before the crisis, okay? So I'm saying that on average, post-war unemployment was about 5.66%, and the real interest rate was about 2%. This is just long-run averages, right? This model has no, remember, there's going to be a continuum of agents and these idiosyncratic shocks that are IID across people, so there's going to be no aggregate uncertainty. Things like the real interest rate and the unemployment rate are going to stay constant in this model, right? Now that's again, not realistic. If you want to, you want to do this right, you got to put some aggregate shocks in. I'm just doing the simplest possible model, okay? So then what I didn't target was the wealth Gini. The wealth Gini in the data is 0.8. The model produces one of 0.38, so roughly 1/2. Surprisingly, if I had asked you beforehand what would happen, I mean, don't look at okay, just close your eyes, okay? What do you think is going to happen in this model? You now kind of have a sense of what this model is, right? Suppose I tighten borrowing constraints. I just want to see how good your intuition is. So let's back up. The model is going to be one where there's basically precautionary savings and borrowing and stuff like that, okay? Now, so why are you saving? Just let's make sure that we got this all straight. Why would you be saving? You want a consumption smooth against states where what's happening? You're unemployed, okay? So you're saving because of this unemployment, these unemployment shocks. So if all of a sudden I, tighten the constraint, right, what's going to happen to the left, basically, well, it depends on where, the left side of the wealth distribution. Because the wealth distribution is going to be over assets, this thing called A. Well, over there it's Y, but it's going to be assets. So you're going to have a cross-sectional wealth distribution defined over A for employed people and unemployed people, okay? Now, the Gini coefficient is a summary statistic of that wealth distribution. So what if I, all of a sudden, just by changing the borrowing constraint, remember the benchmark, I said over here, the benchmark borrowing constraint was you can borrow up to two times your quarterly earnings. So now I say you can only borrow up to your quarterly earnings, okay? So all of a sudden, I've just shrunk the left-hand side of the wealth distribution, okay? Now, if it's harder to borrow, what do you think you're going to try and do endogenously? Did I hear save more? Good, okay, you're going to save more. This is a general equilibrium model. If all of a sudden I want to save more and I have to clear the bond market, what's got to happen to interest rates? Interest rates have to go down to clear the bond market. What does that make you want to do as a saver? Save less, okay? So what you're going to see is that what's happening is both the left-hand side of the wealth distribution And because of the general equilibrium effects, the right-hand side of the wealth distribution are going to start to shrink. Okay? So you're going to get a more compressed wealth distribution. Okay? And that's what actually lowers the Gini. Okay? But that's, I mean, that's how the model works. If you kind of think about what's going on in the data right now, the latest numbers, the really wealthy people are not so well off anymore. Okay? So both sides of the distribution are kind of getting hit. Okay? And that's sort of how you can think about that experiment. Yeah.
So, I mean, this is a model where everyone in the wealth distribution uses the same instrument, the same financial instrument. I'm not sure.
Strong assumption. So, if you have...
I mean, that's fine. I was just thinking in reference to your last comment. I don't know. I would have thought that folk logic to the explanation of the compression of the wealth distribution in the upper tail is something about, capital return as opposed to...
Right. So exactly. So there are models that do this one here. The only way it works is through the channel I just said, but there are models that do that too. And when I show you the data, if I ever get to the data, one of the important one of the ways that the data is organized is about what your employment status is. And the way they're going to, organize the data is to talk about workers, self-employed. So these are entrepreneurs. And it's so that kind of starts to get, if you really want to start to explain the right-hand side of the wealth distribution, the, fat, not fat, but the skinny tail, upper tail of the wealth distribution, you have to you can write down a model, and people have done this, where there's, sort of an entrepreneurial activity. And that goes a long way towards explaining some of this, and it's that's one way to think about some of the stuff that you're getting at. Okay, and then, as I said, so this is the way to, here are the consumption equivalents. As I was saying, that Bob Lucas is kind of a number. This is saying, this is in percent, so this is like 0.2% on aggregate people would be willing to give up to bring the borrowing constraint back out to what it was before. That's kind of what, I'll be more precise in what the actual welfare experiment is, but it's sort of like, the question is, how much would you be willing to give up to go back to the old borrowing constraint? And this is saying like 0.2%, which is not a big number, but it's a heck of a lot bigger than the number that Bob Lucas would have come up with. So it's not I don't want you to, I'm not trying to make any comparisons, okay? But I'm just saying, in the order, some people might say 0.2%, why are you wasting, you've just wasted an hour of our time to get 0.2%, but it's not a small number necessarily, yeah.
Does that number come from the state where everybody's still in the beginning of the game, kind of forward-looking of where you might end up?
Okay, very good. I'm going to, let me save that, because I do at the very end. So for this experiment, I do exactly what you're worried about. So, because during this financial crisis, actually, I've been doing some work on the housing market in the crisis. And, so you read stuff by Alan Greenspan. So this is the chairman of the Fed. And you read in like 2006 and early 2007, he didn't see this crisis coming. Okay, I mean, there's a quote in one of my papers about that. Okay, so that's an unanticipated, I would call that an unanticipated shock, and that's exactly what you're talking about. So, the right way to think about doing this policy experiment, in my mind, is that people wake up and there's the crisis, okay? And all of a sudden, not anticipating the crisis, all of a sudden, the duration of unemployment is now going to be, in this particular example, this doubles the duration of unemployment. The underlying parameterization said the duration of unemployment was 2 quarters. That's high, frankly. That's a bit high, okay? But it's kind of like, I could have put 1, and that would be a bit low. I could have put 2. I put 2 and it's a little high, but that was how I did a little bit better on the wealth Gini. But so this actually says that the duration of unemployment, this parameterization in the mobility matrix says that on average, I stay unemployed for 1 year. Okay? And it's like, so the experiment you want to do is I wake up in the morning and all of a sudden, everybody is going to start to be unemployed, that gets the unemployment shock for now a whole year. If I was anticipating that, so, this example is, I'm not anticipating it, right? So, but back here, if I anticipate that I'm going to be unemployed longer up there, what would I start to do? Well, by the way, in a steady state here, what do I, in the steady state where durations of unemployment are going to be longer, remind me, what are people going to do? Will they save more or less? Remember, this is not when you're in that particular state, right? This is in a steady state of a model where you face, longer spells of unemployment. What would you do in that kind of an environment? You want to self-insure, right? So you would want to save more, okay? But given that, when do you want to do it? If you anticipate it down there, you want to start doing it here, right? When the duration is lower. So you would build up what you really need to do is think about a transition to the new steady state. And that's how I interpret your question. And I'm going to do that at the end of this lecture if I get there at some point, okay? These numbers are coming out comparing steady states. Okay. All right. And but the consumption equivalent. So again, let me just say, because you just told me that in both of these cases, people want to save more. If people want to save more, as Corinne said, the interest rate is going to drop, right? In order to clear the market, in order to get people, the market to clear, if everybody wants to save more at the given interest rate, the market can't clear, so the price has to drop, right? Or the interest rate has to drop. So that's what you see here. A longer duration of unemployment implies that the actual unemployment rate, the average long-run unemployment rate would be higher, okay? It has, unlike this case where there was this compression, okay, the wealth Gini with the longer duration of unemployment, you're going to have, with a longer duration of unemployment, when you're unemployed, people are going to be dissaving, right? And so it's going to change the wealth distribution a lot, and it actually raises the Gini coefficient to 0.49, okay? So that's like a 25% rise over this. And it has extending the duration of unemployment has big welfare effects, okay? I mean, the right way to think about the welfare effects for reasons like what Stephen was saying, that interest, these numbers, I'll show you how to compute them, all depend upon the preferences that you put in and all that kind of stuff. So it's kind of good to kind of calibrate your idea of what welfare effects are relative to the experiments that are going on. That's why I keep on using the Lucas example. That's an example of his, one of his numbers was really for a set of a coefficient of relative risk aversion 1.5. So these are pretty big numbers. Okay, I kind of went through this, so, but just to be, this just explains what we just said, and these are the words behind that table. So I'm going to pick up 2 slides. Okay. Okay. So now remember, I need to basically think about the data that I want my model to talk about. Okay. So I have 2 sources for, this is kind of like a macroeconomist take on the data. And I know you guys have seen, Jim Foster has done some stuff. There are way better people than me to talk about data, okay? But here I just want to kind of give you some sense of the data that I'm going to use in this that I want to match and things like that. And it really, the two papers, it's just these are nice, simple summaries of the data, okay? Okay, so, and what are the two data sets that these summaries, I guess I should have, before I go into the data, that was the introduction. So now I'm on to that other, 1 hour into it, I'm just getting to here, okay? But it's a good place, if there are questions, hopefully none, I'll take them. Okay. Okay, so let's kind of think about the data. Now, a good data source for because remember, I'm going to be doing this stuff just thinking about, I'm going to take the earnings inequality data kind of as given. And what I'm really interested in right now is thinking about wealth inequality. So I have to go to a data set that has good wealth data, right? So in some sense, the best data set for wealth inequality that we have access to is the Survey of Consumer Finances, and it's kind of run right out of here, out of University of Chicago. So this has really detailed balance sheet, pension, characteristics of U.S. families. It's, I think it's, sort of triannual data. It's not very big. It's 4,500 people. And the problem is this data, because, we're kind of thinking about the wealth distribution stuff, and there's not a lot of wealth on one end, it basically overrepresents the wealthy, okay, the rich. So I want to say all those things about this data, okay? Now, the final thing that makes it not so great is if I'm going to take a model where the earnings process is, I'm going to have like this mobility matrix for earnings, it would be nice if the model itself had, was a panel so that I could actually calculate, what's the probability. So this mobility matrix is like, what's the probability that I'm in the first quintile, or, in this particular case, it's going to be that I'm unemployed, and then after a model period, that I'm employed or unemployed, right? That's what the mobility matrix is going to be. So you would kind of want to follow the same household, right? But this is a cross section. So you can't actually use the Survey of Consumer Finances for that kind of a calculation. Okay, so what the mobility numbers that I'll show you at the end of thinking about the data, they're going to come from the PSID. Okay, and that's from the University of Michigan. That has a lot better demographic data and things like that. It just has less of, this balance sheet data. Okay, but both are for certain questions you want to use the Survey of Consumer Finance. For other questions you might want to use the PSID. Okay, there was going to be a question.
The first question you put up was, to what extent does earnings inequality explain wealth inequality? In the context of the model, should we think about wealth as being people's holding, people's savings?
Yeah, I mean, and so that's going to be, what I'll actually have a definition. How do I think about wealth in the model? So our model is not going to have, there are not going to be many different, just as you were saying, you could think about there being bonds and stocks and all that. That's in this detailed balance sheet, okay? I would, what's another really big asset? Housing, good. That's in this balance sheet, okay? The way that I'm gonna, but remember I kind of said the model, oops, over here. The model is going to generate, I'm going to have earnings shocks, that's what the XT is going to be, and I'm going to have this thing called an asset, and it's just going to be one asset. So I'm going to have to think about an asset as your net worth, okay? So, you know, when it's negative, you have negative net worth or wealth, and then when it's positive, you have positive net worth. Yeah, so it's going to be basically all those things. The way I'm actually literally going to think about wealth when I calculate Gini's, I'm going to kind of think of, you get your earnings, it gets direct deposited into your checking account. So then that forms a part of your wealth, as well as your, you know, bond holdings. That's going to be wealth in the model. But I'll go through the definition of it in a second. Okay, so I just want to go through just really quickly a couple of definitions just to make sure, because some of them influence the numbers you're going to see. So the definition of a household is a person or a couple who live together, and all the other people who live in the same household are financially dependent on them. The Survey of Consumer Finance is, you know, it's going to sound sexist and stuff. It considers the male of a couple to be the head of the household in every case, okay? In single households, the financially independent person of either sex is considered to be the head of the household. When I show you some, you know, how the data gets sorted on certain characteristics like age, you can think about them following cohorts. They're gonna sort the data on I'll show you data on a lot of different ways of sorting, a lot of different cuts of the data. Okay, so here are the definitions. This is going to be more to what you. So the actual in this paper, okay, or these two papers, the definition of earnings is going to be wages and salaries plus a fraction of business income. The way they measure this 0.86 is to kind of think about how much is coming from things like you know, capital income and stuff like that we don't think of as part of earnings. We think of that as part of income. That's why they only take a fraction. They don't have detailed data on the business income. That's why they take a fraction. That's where that number 0.86 comes from. But basically, I just want you to, you know, think of this. Earnings is going to be wages, basically, that people make. Then income, the way they're going to measure income is actually they're going to throw in transfers, but not put in taxes yet, okay? So you'll see that affects the you know, inequality, and you might imagine that if earnings are kind of unequal, but then you throw in transfers, but don't tax yet, what's going to happen to income relative to, I mean, it's not necessarily the case because income is going to also include like interest income, dividends, capital gains, and all that kind of stuff. But I already know what the answer is. What do you guys think which is going to be, is income or earnings going to be more unequal? It's not you don't know the answer yet. I mean, you can't tell me because there's two parts to it, but let's take a guess. Are going to be more unequal? Yeah. Okay, that's what's going to happen. And you know, a lot of that's going to come because of these government transfers and stuff like that, okay? When you see the actual histogram, there's a lot of zeros. In, you know, like the first quintile, you look at earnings, lots of zeros. You know, like there's a zero. That's kind of, but you don't see that zero when you have transfers in there. So, you know, what are some of the things when I show you the data? It includes earnings, interest income, dividends, capital gains and losses, you know, from real estate and stuff like that, unemployment compensation, Social Security, child support, food stamps, blah, 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 okay? All right, so that's going to be the definition of income, and I'm actually not going to put up any of the, I mean, some of the summary statistics will have income in it, but the two main tables with all the data I'm going to kind of just put up the earnings and the wealth one, because those are the two that I'm going to use when I start thinking about seeing how well the model works. So wealth in this kind of a framework includes, you know, financial stuff like checking. So that's why I was saying I would include that. I'm just thinking of people getting direct deposited cash is also included in it. Bond stocks, blah, 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 blah. So all these things, real estate, and then you have to subtract out mortgages, et cetera, right? So that's going to be, the definition of net worth is going to, take, for instance, you'll have your house, right, where it was a residence, but I'm going to subtract out the mortgage on the residence, okay? So, recently, typically people had, before the recent crisis, people had positive net wealth in their house, right? If you have a 20% down payment and the house price doesn't change or it goes up, what do you have? Just from that accounting. You have at least 20% net wealth from your housing. But if you have a housing downturn, right, you have a mortgage that's, say, $100,000, you have a 25% drop. That's what happened in the recent crisis. If you have no down payment, or even if you have a 20% down payment, but you have a 25% drop in your the value of your house, and you just recently, got the house, what's just happened to your net wealth? That's gone negative, okay? And the thing that's interesting in this latest, this crisis, if you look at the data, I can talk about this if I have any time at the end, but this is something I'm doing with a guy in the real estate department at Wisconsin. If you look at the data, there's been a huge increase in origination, at least between 2003 and 2007 when the crisis hit. Originations of 0 down payment mortgages, it was a huge run up in those, okay? So then what's your net wealth? If you have a 0 down payment, immediately what's your net wealth? Before it was 20%, right, because you had a 20% down payment. Now it's 0. Now you put a 25% housing drop down, what's happened to your net wealth? You're in a lot of trouble, right? Before you were only 5% underwater, now you're 25% underwater, okay? We can talk about that stuff after, but this is all the data. By the way, when they make comparisons in this in these papers, it's all it was from 1998, and then they're comparing it to 2007, like 1998 Survey of Consumer Finance and 2007 Survey of Consumer Finance. So, that was before, in essence, this crisis. So you have to wait until the next, Survey of Consumer. So the 2007, the next one was 2010, and the survey, I can't remember if it's actually come out yet, but there's not a paper written on it yet. But that's going to be a really interesting Survey of Consumer Finance, okay? Yeah.
So I'm just wondering what you just said, how this fits to the general framework which you presented before, because you were just saying that basically wealth is also subject to shocks, right? So like, not in your model, but like in the real world.
In the real world.
So how do you?
Yeah. So
how does that kind of fit together?
So
because yours coming out as an endogenous.
Right. So I'm not going to have. There are not going to be separate shocks to the wealth distribution.
So you're assuming that this kind of. But, okay, so how
all of it's coming. I mean, that's why I can't explain a ton, right? Now, okay, so there's something else I've done some work on, and we can talk about this after, which is thinking about bankruptcy, Chapter 7 bankruptcy. And that's how this exogenous borrowing constraint, this model is going to be one in which people do not declare default, okay? In this particular framework that I'm about to write down, you always pay back, okay? That's not in the data. So a guy named Satyajit Chatterjee, Makoto Nakajima, and Victor Rios and I wrote down a model where you do actually have a default option, and it's according to Chapter 7 bankruptcy. Now, in that, when we wanted to try to match the bankruptcy data, it was actually very hard. We have in our paper, we have basically, we've shut down all the shocks except for the earnings shocks, and it's very hard to match the data. But if you look at the PSID, in the PSID, they ask you certain questions for why you went bankrupt. So one of them is like unemployment, Another one is like mismanagement. I don't know how to think about, that. That's just saying, well, no, that's actually a good, yeah, exactly. So that's actually, so I was about to say, I don't know how to think. I can't use my model to think about that because I'm having people be totally rational. But I think that there is a place in the inequality data to think about people that are not totally rational. These models are going to be, people are going to be totally rational. But one of the other, lines in the survey is things like, medical shocks, and that's a major portion in the survey. That's a major portion of why people go bankrupt. So when we took that model to the data to try to understand Chapter 7 bankruptcy, we had to actually we actually added a health sector. and we had, medical shocks to try to understand, to try and explain more of the bankruptcy data. Okay, but that's sort of like along the lines of what you're saying, that I need to add more shocks in order to match the data better. And those shocks were not to your earnings necessarily. We didn't model it that because of a health shock you weren't able to work and things like that. We just, we took it a little bit less deep way of thinking about it. But that's exactly the kind of stuff you're talking about. Okay, so these are the definitions. Okay, I know you all know this, but I'm a macroeconomist, so I had never seen this before until I, started working with these models. So let me just, so that we're all on the same page. So a Lorenz curve, it's basically just the cumulative distribution of wealth or income or earnings. So it's sort of like the way I would call it is like if I'm doing quintiles, the bottom 20% of all households have 10% of wealth. That's the kind of the way I kind of think of it. So, a perfectly equal wealth distribution, everybody has the same wealth. In that case, there's, 20% of the people have 20% of the wealth. If it's perfectly unequal, then, basically, let's say no one has any wealth until the last guy, and then they have all the wealth. So, the bottom line is the measure that we're going to be kind of thinking about, this Gini coefficient, is just basically, a normalized amount of the area underneath the line of equality. So more unequal, right, means more area under that. So the Lorenz curve would be shifting down in this direction. Okay? And again, just to keep things straight, the Gini coefficient, I know you all know that. It's just that area that I was just showing. So just keep in mind, perfect equality is 0, and perfect inequality is 1. So when I put up the data, you saw the wealth distribution was 0.8, very, very unequal, right? Okay, and then this mobility matrix, just the way we're going to think about the mobility matrix is, I'm going to, for instance, the way it's going to be shown here is they're just going to take quintiles, so it's going to be like a 5-state Markov process. And you take the lowest quintile person in one period, and then you track them in the PSID and see where they went the next period, okay? The next sample. Okay, so I'm going to put up a few, and you're not going to be able to see them. I can hardly see them unless you have them in front and you put it on 300 or something, okay? So these were actually from 98 because they didn't put them in the latest working paper. So these histograms are going to be from the Survey of Consumer Finance in 98. The average earnings at that time, these are all in terms of real earnings, was $42,370. Again, remember that was 1998. Okay, these are, so I just want to kind of show you, this is sort of what I want. So again, they've all been normalized, and so there's a, at 1 is actually the mean, so average earnings is 42, and that's right here at 1. But I kind of want you to, so what are the things I want you to see? So first of all, we want the model. I mean, I want to write down a model that's going to generate something that generates a histogram, okay? So the histogram I want it to kind of generate is kind of something that looks a little bit like this, okay? So anywhere below 1 on the normalized level would be, people starting, or below 0 would be people starting to borrow and stuff like that. But the key thing is, I just want you to see, here's the data. This is what the model you'd want to explain. You'd want the model to explain by inputting a exogenous process like this. Okay, that's the way to think of it. All right. By the way, the one you see a huge, at 0, there's lots of people in terms of earnings. All they did down here is take out basically retirees, right? Because retirees are not earning a lot, and that's what this bottom panel. So, just if you go back to and look at the data, if you go to these sources, you'll see, here's earnings, here's income. I defined each of these, and here's wealth. But this spike, they want to kind of think about this spike. So this is like 28% here. And that's because they've included retirees. When you take out retirees, you're down to like 13 here. Okay. What are some things that so now we're just going to kind of do a broad kind of survey of things and quickly go through. I'll tell you what, I definitely want to start, I want to get through this and then start on, at least start the structural stuff, the model. So I'm going to go through this kind of quickly. So, what do we see in the following, in what I'll be showing in the next set of graphs? Wealth is more unequally distributed than earnings, while income, since it includes transfers, is least unequal. All measures of inequality have been rising. The mean has been growing relative to the median, and that's why I was saying that has a potentially important, kind of implication for political economy models. So this is from the 1998 Survey of Consumer Finances, and all you can see, the part that you can see here, the Gini coefficient is going to be, because the Gini coefficient is this distant, this area. For income, it's going to be the lowest. For earnings, the next, and for wealth, the largest. This just basically kind of shows what they do is document certain measures, like what's happened to Gini indices. And so I don't know if you guys can see it, but here are, so what are the different axes? So this is dates, 1998 and 2007. Here's the Gini for earnings, income, wealth, and then non-housing wealth. Remember, keep in mind that this is 2007, so the crisis hasn't happened. So what you see is that all the Gini indices have gone up, right? So there's more inequality. All the mean to median ratios have gone up over time. There's actually a lower coefficient of variation, which again is standard deviation over the mean. That's actually fallen for wealth, but for the other things, like when I was talking before about the fanning out of the earnings distribution, that's you can see the fanning between 98 and 2007 by a rise of the coefficient of variation. This kind of, you can kind of see it here, but these are averages across all, but this kind of gives you a sense of who's kind of been doing well and who's not doing well. It's actually kind of like this kind of says the middle class are the ones that are not, are getting kind of screwed the most in some sense, okay? Okay, earnings statistics. This is going to be a huge, so here's the table that I know you can't see, okay? Hopefully some of you have this on. Since you can't see it, I'm going to summarize it for you, but I guess what I think is kind of a nice thing, these tables, table 4 and table 6 in their paper, it just has lots and lots of slices of the data, okay? So what this first here is like, when I talk about the the poorest and poor, it's going to be the very tail of the distribution. And the rich and the richest, that's going to be over here. And then in the middle of this table are basically the quintiles. Okay? The first thing just basically is the raw data for how much people are making in each of the quintiles. It's times 10 to the third 2007 dollars. And one of the things that kind of jumps out at you that you can't see, but I can see, is the bottom percent. So this is the bottom 0 to 1%. What you can't see is that earnings here are minus 9.1. And what you can't see is that wealth is actually really high. Okay? Now, how might you explain that? I'm going to point this clicker right to your forehead. Because that's the entrepreneurs that we were talking about before. Okay? These are people that, in some sense, these are business losses. That's what the minus 9.1 is. And this is, they're actually pretty wealthy. Okay? So that's, when you look at the first quintile, and you look at so here are zeros for earnings, right? For people that are really poor. But that's not those are people that are, chronically poor, earnings types. These are the, this part, when I said that a model, if we want to write down a model to better explain the wealth distribution, maybe we need to include entrepreneurs in that model. This kind of is why you can see that if you want to explain the data, you might need to put them in. Okay? Yeah.
I think you answered this question before, but how does this data deal with the household unit? I mean, earnings.
Yeah. So this model is it's the households. So this is the head of the household earnings as well. So it doesn't do a good job at kind of aggregating things that you would want to aggregate.
But so earnings is just head of the household earnings. Wealth is total wealth of the family.
Yeah. Okay, and then let me just say, so these tables actually would be how you would think about the Lorenz curve. These are the different quintiles for the Lorenz curve for earnings, income, and wealth. This gives, what the sources of income is for these people, which is, I think, an interesting slice of the data, right? So here you can kind of see for the really poor people, again, this is how, you kind of know it, the business income for people that are, poor but not really poor is 0, because they're, again, not doing anything. But the business income for, this poorest group is minus 16. Okay, so that's again, these entrepreneurs, all right? Another slice of the data is obviously just something like an age slice, so that's here. I'll kind of talk about another slice of the data is education, that's here. Another slice of the data is what people report as their employment status, so the different ones that they report are they're either a worker, they're self-employed, so that's the entrepreneurs tend to be. They're retired or they're non-workers. So an example of someone that might be a non-worker is someone on disability. It also talks about marital status, so that would be sort of starting to think about putting a family in. So we can see that basically if you want to be in terms of wealth, the wealth distribution, a lot of these people. Wealthy includes a lot of them are married, so that gets it sort of starting to think about the family institution, stuff like that. And then they also break it up in terms of excluding retired widows. I mean, one of the issues is if you look over here, there's a lot of people who are in the lowest quintile that are, that are basically single. And so what they do is they pull out retired widows, and then the numbers, start to drop here. Okay, so just to summarize things, the wealth poorest have average net worth of minus 79,000 and tend to be young. For the young, the debt tends to be student loans. So that's something that, again, these models like what Lance was talking about, where there is borrowing and an endogenous choice of education, that might be kind of important. Some of the wealth poorest are retirees who have outlived their savings. Many of the wealth poor are high school dropouts. That's one of the things, you can also see. I'm summarizing the wealth. I had summarized the earnings stuff, before. This is all in that. So I'm summarizing this table here. The wealth richest hold 34 times the sample average for people in the sample. So they're really rich, right? And they tend to have it coming from all different sources. Many of those wealth richest are self-employed, so they're the entrepreneurs. One of the other things you'll see in the model that I draw, I'm going to have a Lorenz curve that's going to have this negative portion to it, and that's consistent with the bottom quintile and the wealth. That's consistent with, I don't know if you guys can see it, but this is the only number here. This is like part of the Lorenz curve. It's the only number that has a negative number there. Okay, so quickly to summarize some things. There are two tables that say, inflation-adjusted average earnings, have all risen. The tables kind of, just the averages, if you just take literally averages, that hides certain things. So the median, in the sample had the least gains, while the rich had the biggest gains. That's, from table 7 and 10. That sort of, I had shown something that looked a little bit like that earlier, so I won't go long into it. Inequality in age. I mean, we all know that there's a hump-shaped earnings distribution, and I'm not, as I said, the model I'm going to put in doesn't have that, okay? But, there hasn't been big changes in that over the last 10 years. This is the table. How do you see the hump shape? Turn your heads like this, and here's age, and here's earnings. So just less than 25 is, that's at 25. The peak earnings times in this sample was 51 to 55, okay? And then it starts dropping down. Over 65, it's back down to 19, okay? This is graphically a look at that data. So again, you see, earnings, this is the earnings process in the basically average earnings in the data. That's the hump shape that we always talk about. You see wealth start low, so people are accumulating wealth in here, and wealth peaks at around in the 61 to 65 range, and this is people saving out of their savings for retirement. But one of the things over here, this is the cross-sectional. I just want to make sure you see that there's a lot of heterogeneity even over time. So when we take the whole everybody in the distribution, we're mixing all the ages, right? So it's not so surprising if there is earnings heterogeneity associated with age, then when you mix everybody, you should have, you'll have inequality just because of the age part. But what this shows here is even for a given age, right? These are the Gini coefficients. And what you see is there's a substantial, this is 0.4, right? So what it's saying is there's substantial heterogeneity, even in a given age, within a given cohort, there's substantial heterogeneity, right? And again, I don't think that this is surprising to you guys, but I just want to make sure that, that kind of stuff. So the model I'm going to write up, there's going to be no age, but there is going to be, so there's one cohort, but there's going to be heterogeneity in earnings, and that's consistent with the fact that there's even conditional on age, there's heterogeneity in earnings, okay?
Does
Yeah.
this tail on the earnings inequality, is that, retirement timing mostly?
Yeah, yep, exactly. Okay, education. I mean, I'm sure Lance said a lot about this. I just want to say, the college premium is 5 times more than dropouts and 2 times more than having some college. There's more earnings inequality among dropouts than higher educated people. And Table 20 shows that a lot more people are becoming educated. Since we can't, I think you guys can't see the table, so I don't know why I'm putting this up. It's just to show you where you could look at it if you pull it up on your computer. Okay. This is, again, I think this is something that's kind of a nice slice, again, that people, I don't know if it's in a lot of different, that you've seen before, but what they do is they slice things, partition things into people being workers, people being self-employed, people being retirees, people being non-workers, So that's a pretty broad statement. So it could be a really rich person that doesn't work. It could be a disabled person, et cetera. What they find is that basically these self-employed entrepreneurs, if you look at this distribution, well, not this one. You'd have to go back to this table. The self-employed, they have, there's a lot of them. They're way oversampled in the data on the top of the earnings quintile. Okay. So it just, again, it kind of says that maybe it would be good to have a model where you put in entrepreneurs if you want to explain that right tail of the distribution. Married, which is 60% of the sample, have higher average earnings and lower earnings inequality than singles. That's another thing that I'm not going to be modeling in this. And so that's why people like Stephen Chiapuri is going to be talking about that stuff, I guess, tomorrow. Okay, finally, I just want to say one quick thing about financial status. So this is to try to this is to start to understand questions about bankruptcy. And I just want to, since foreclosures have risen a ton, that's, foreclosures are one form of, default. This is really, they're asking questions about bankruptcy. They can't actually tell. In the US, there's Chapter 7 bankruptcy, there's Chapter 13 bankruptcy. The survey doesn't do a good job of saying which one, okay? In the US, 2/3 of all bankruptcies are Chapter 7. 1/3 is Chapter 7, you don't even know what that means probably, right? So Chapter 13 bankruptcy is where you basically go into a court and you're in front of a judge and he or she figures out a repayment plan over the next 5 years. And then, you basically, it may not even be that you pay it all back, but that's basically what a Chapter 13 bankruptcy is. A Chapter 7 bankruptcy is they basically wipe out all of your debt there are certain kind of, certain assets. In certain states, they can attach to your house. In other states, they can't attach to your house, things like that. So they can attach just in Virginia, you get to keep a thoroughbred horse, okay? So, I mean, there's a lot of cross-state heterogeneity in bankruptcy laws, and I think that's kind of important. If you want to think about data, this kind of cross-sectional heterogeneity is potentially very important, okay?
You actually see people investing in horses?
One important thing. Yeah, so certain places, so in certain places you can keep your house. I think also in Texas. Also get to keep your belt buckle in Texas too. I lived in Texas for 10 years, so I've seen enough belt buckles in my life. All right, so one of the other things, I'll talk about this a little bit later on when we start thinking about models, but the one key thing I want you to see in this data actually is, most of the people, you hear these stories, these really rich people, and it might be influenced by things like people keeping their house in Florida, but you see, you read one story, or two stories about these rich people declaring bankruptcy and stuff. When you look at the real world and at all the data, the bottom line is most of the people that are going bankrupt are just plain poor, okay? And a lot of times it's medical expenses and things like that they're declaring it on. Now, the only reason I want to focus on that a little bit is that that's in some sense a data moment to test models, okay? Now, I don't know how many of you, so how many people here have seen like a model by, it's by Tim Kehoe and David Levine. These are endogenous borrowing constrained models, okay? So this is a little advanced macro kind of stuff, okay? But there's a whole big part of Sargent and Lundquist that does that, okay? Now, in those models, so first of all, in those models, so for those people who've seen that, you have to answer this. Is there any default in equilibrium? No, okay? So you can't even see the date, there are people that answer, I've gone Chapter 7 bankrupt. That's not in that model, okay? So you have to write down a different model to be able to do that, okay? The other thing is, in that model, for those people who have seen that model, when is it that so that model has, it's a terrific model, so don't get me wrong, I think that is really important work, okay? Because, you want to explain the borrowing constraint from underlying frictions in the environment. That's cool, okay? So then they put in commitment problems as, the underlying friction, and they get an endogenous borrowing constraint. That is very, very cool. The commitment problem, the friction says, I could default and then leave the environment, sort of leave the credit markets altogether, go into autarky. That's the kind of off the equilibrium path behavior, okay? So, and then what they do is they kind of say, well, when does that constraint bind, okay? So for those people that know those models, when does that constraint bind? Well, I'll tell you, the constraint binds when people have a lot of earnings. So, the binding constraint says I'm indifferent between staying in or paying, paying back or whatever, and defaulting. Given that I'm indifferent, as a modeler, I'm just going to say they don't default. But if they defaulted, because they're indifferent, if they defaulted, what state would that be, is the question. Turns out the state is when you're very rich, okay? You look at the data, the people are poor, okay? So this is not to say, it's just that framework is maybe not a good framework to think about, default, Chapter 7 bankruptcy and stuff, okay? So there is a class of models that does that. I'm kind of touting this because I have a paper on that, but there's, and this stuff is kind of, people are employing that kind of work to think about, so Lance's paper, I don't know how much Lance talked to you about it, but his AER paper, he has these guaranteed student loans, and then he has another option where there's private lending. And in the private lending part, he allows there to be a bankruptcy. Basically you can default on that, okay? And the framework that he uses, the kind of framework of defaulting is kind of, there are incomplete markets. And that's kind of where, you look at the data on student loans and they're thinking about making them more contingent, right? That's part of the policy question. Should we forgive people's debt, even the government, who don't make a lot of money, right? That's a very contingent kind of a contract, right? The kinds of, these models, that I'm talking about right now, they don't have contingencies. That's the form of incompleteness, right? You have to pay back. But you realize that if you have incompleteness in the contract, suppose you have a non-contingent bond, right? But then you put in a default option. What does that make in allocation? Adding in a default option does what? It makes it more, I often play hangman. Does anybody know what hangman? So it would be, it's like about, let's say 9 letters. More, I'll give you the first letter, C. Complete? More complete or contingent, exactly, okay? That's what the default option does. It takes a world that has incompleteness and perfect incompleteness, and then makes it a little bit more complete, right? That's how policy can kind of turn private financial markets into something a little bit more complete, okay? All right. Okay, so let me, I just say, that's the summary of it. These actually, who are the people that are defaulting and delinquent and stuff like that, we can kind of talk about that as well. Okay, inequality and mobility. So, this is going to be important for the model I write down, because as I said, I'm just going to have a two-state, over here, I'm going to have a two-state Markov process, right? So what I'm about to show you is, and this again now is from the PSID, these are 5-state Markov processes, where from the PSID, basically what they do is they take people, these are quintiles of the earnings distribution, right? That's this side. These are quintiles, I guess, from 2001, okay? And these are quintiles from 2007, okay? So then they take people from the first earnings quintile in 2001, and they track them into 2007, and they say, where did they end up? Okay? So what are the things that we should kind of see from this? The first thing to see is if you look at each of these, so, okay, I gave this definition before, basically the rows have to add up to 1, right? So on the diagonal, so that's the likelihood that a person that was in the first quintile, earnings quintile, in 2001 is in the first earnings quintile in 2007. So what you see, so there's a high likelihood if you're in the first earnings quintile in 2001 of staying in the first earnings quintile in 2007.
Why are quintiles an actual object to look at?
It's not.
In particular, it's really not the possibility that everybody does worse.
Yeah. That. I agree. There's many different ways to measure.
This is a very substantive restriction in terms of asking about movements in relative status, where you're on poverty, that's a different question.
I totally agree. I totally agree.
Is this cohort contingent at all? Because this could just be saying if I'm retired in 2000.
Well, okay, so here's your question. So that would be one in which basically you take out, if you take out the people who had 0 earnings in both 2000 and 2006, so I guess it's the survey is conducted 1 year, after the actual, they're asking questions about last year. So that's why you get 2000 and 2006, the survey's done in these periods. So you take those people out that you're talking about, and the mobility rises a lot, right? So you take out retirees who tend to be, earning 0 both in 2000 and 2006, and you see that mobility, this number, 0.56, is a lot lower than 0.73. So there's less people staying there. So that's exactly what you're getting at. One thing to kind of, so that's really about this one here. But even when you go down here, right, this number is a lot, a lot higher than the rest of them. So what's this? Let's just go through this one more time. So this is people staying in the second quintile, between 2000 and 2006. But what you can see, these are a little bit bigger tables. You can see that they're all, the predominant number is on the diagonal. So that's saying that in some sense, persistence is important, right? That's all that's saying, that people tend to persist in their quintile, okay? This doesn't have any earnings. So this guy, Victor Rios Rule, he loves to talk about the American dream and the American nightmare, okay? So here, the American dream would be going from here to here, right? Not much of that happens, right? People understand what I'm saying? So just going from the first quintile to the fourth or fifth quintile. At least in the PSID, you didn't see any of that. You see very little into the fourth. You see very little into the third. But you see this upward mobility, right? You don't stay here. You go up, right? The American.
How come it's more likely that you move to the wealth distribution from the first to the fifth?
So I think that's a lot of that again has to do with this this entrepreneurs making it big. Okay. So and then where's the American nightmare? The American nightmare is being here and going down to there, right? And you see some more nightmares than you see dreams. Okay, but this is the, to finish up, I'm now kind of basically done with thinking about the data. So we'll take, this is just a natural place, I guess, to take a break. But what we're going to do in this model, just to keep things, like I said, I want to give you the simplest possible model to think about this stuff. And all the things that you're asking me are really good points that I would want to modify the model and make it a little bit more complicated. But if I want to give you the simplest possible framework to think about this, what I'll do is I'm going to take a two-state earnings mobility matrix. So it's going to be a lot smaller than this. That's going to be my exogenous shock process. I'm going to feed it into a model where there's going to be parameters. And then I'm going to get out things like savings decision rules and the cross-sectional distribution of wealth. And then we're going to start to ask questions about, I won't actually have anything like wealth mobility like this, but I'll summarize the wealth distribution through the Gini coefficient. Okay? That's what we're going to do next.